started, having a look at this topic, the different things we're going to be going through, we're going to be reminding ourselves about the gradients of lines and how you determine different equations. We'll start getting used to the idea, though, of equations being written in a slightly different way. They're not always going to be written with y as the subject. Sometimes the questions will want you to write things in a particular way, where you have ax plus by plus c equals 0, where a, b, and c are integers. Nothing difficult, but just something that feels more A-level, and I just want us to be aware that that's what they're going to be asking about. We just talked about parallel and perpendicular lines. We're going to keep building on some of those ideas and do a lot of practice, because this skill needs to be done perfectly. Then it's the number 3 and number 4 is where we move into a lot more of a more kind of like A-level style. It's called coordinate geometry because we're talking about coordinates, we're talking about the x and y axis that we would draw things, and geometry because we're also going to be talking about shapes that might be happening in that coordinate, which is why we're interested in finding the lengths of things and also the areas of different shapes as well. The last thing, which is definitely the most new, is modelling. And we've talked about when we did some modelling before. When did modelling pop up in one of our previous topics? With quadratics, yeah. And what kinds of things did quadratics model? Can you remember any examples of things that quadratics modelled? Good. We talked about like a rugby ball being thrown and how long that took for it to hit the ground. We also did an example of someone as an archer firing an arrow. And lots of things in real life will have models of straight lines as well, especially if any of you guys have done economics at GCSE. Lots of things in economics can be modelled as linear growth. This is an area that actually I think some teachers in the past would just say, oh, they'll be fine, they'll be able to do that. But I want to just make sure we spend enough time on that because it comes up in every exam and they always make it kind of come up a little bit weird, a little bit different. So we're kind of gearing towards making sure we can do these kinds of questions too. Okay, so starting at the very beginning, keeping it super simple just to see that we're all on the same page. I want you just to talk to the person next to you. It says, what is the equation of this line? I'm obviously talking about this blue line that's here. But the most important thing I want you to see if you can explain to someone is why is that the equation of the line? So I'll give you 30 seconds. What's the equation of that line and why is it the equation of that line? Okay, I'll start off. Tamim, what is the equation of the line? And what's your explanation of why that's always the equation of the line? Good. At any point on this line, absolutely any point on this line, the x-coordinate is 2. It sounds like a very obvious thing to say, but I just wanted to make sure if there was one person in here who didn't know that that was why it was x equals 2, it's just about making sure that everyone is all on the same page. And actually, I like to think almost like the line is, if you imagine every single possible point where x is 2 as coordinates, so it's almost like the line is all of those points like merged together into one long line. That's really what the line is. It's like the locus of all the points that where x is equal to 2. And this is something, I suppose, that's quite obvious. It says a line consists of all points which satisfy some equation in terms of x and y. So I've got here Mr. Bison's line club, and the membership rules, it's a bit difficult to see that, say 2x plus y equals 5. So it doesn't look like a traditional y equals mx plus c graph, but I've got here 3 pairs of coordinates, and we want to see actually, are these coordinates members of the line? So I just want you to have a quick think. Those 3 coordinates that we've got here, here, and here, which of these ones do actually land on this pink line, and which ones don't, and why? So I'll give you a minute to decide which of these 3 coordinates do lie on it, and which don't. Okay, off you go. it's just swapped around so that on Thursdays, the Thursday lesson has swapped you all with Mr. Udin when you would have usually been with me. So this Thursday, you're in here in this classroom. Okay? So you need to look at these coordinates and decide whether the x and y coordinates make that true or not. Okay, good. Okay, so that's probably about a minute on that. Does the first coordinate we have here belong on the line? No, because 2 times 3 plus 2 is equal to 7. So this one does not belong on the line, so I'll put it in the trash. What about this one that I've got here, the 3 and the minus 1? Does it belong on the line? Yeah, it does, because 2 times 3 is 6, minus 1 is 5. So it probably belongs somewhere on that line there. Maybe it probably belongs actually a bit further down here. And what about the 0 and the 5 one? Yeah, that's obviously going to belong on it, because 2 times 0 plus 5 does belong on the line. Again, it probably seems like I'm labouring the point here, but if it makes the equality true, then these things actually do live on that line, which means that they are coordinates that are on it. So what this really means that we can do is we can substitute the values of a coordinate into our equation whenever we know the point lies on the line. So this example that we've got here, we've got a couple of examples and then we'll be doing a lot of practice later. It says the point 5a lies on the line with equation y equals 3x plus 2, determine the value of a. Well, all this really means is that x is equal to 5 and that y is equal to a, because obviously it goes x, y in the same order as the alphabet. So we can take these two values and we can substitute them straight away into y equals 3x plus 2 to create an equation. So we get a equals 3 times 5 plus 2, which is 17. So it's just a reminder that when you get given a pair of coordinates, x and y can go straight into the equation that you have as well. The second example that we've got, it says find the coordinates of the point where the line 2x plus y equals 5 cuts the x-axis. So this isn't going to be a sketch of that particular line, but if we're just thinking about where a line crosses the x-axis, what do you know when something crosses the x-axis? Y equals 0, and that's the main mistake that people usually make. So when it cuts the x-axis, y equals 0. So all we're going to now say is that y is equal to 0. So we get 2x equals 5. So x is equal to 5 over 2. When you put that together as a coordinate, because it does then say to find the coordinate, you'll notice that you've got 5 over 2, 0. The good thing here is that we actually have an x coordinate, because we wanted to know where it cut the x-axis. If you had 0 there, because you said that x was 0, then it wouldn't make any sense. We're trying to say where does it cross the x-axis. It's good that the y value is 0 and the x value is something that is non-zero there. Okay? So you've got a couple of things on the next page. All I want you to do is to very quickly find where does it cross the y-axis and where does it cross the x-axis. So the question that you've got here is where it says your turn. So have a quick go at that. I'll give you 1 minute to have a go at trying to find out where it crosses the y-axis and the x-axis. Okay, nearly done? Yeah? So Hassan, if you can help me with this first one. When it crosses the y-axis, what do we know? Good. And so what did you know? What was the first thing that you substituted in? If it's crossing the y-axis, that x is equal to 0. So we just get 2y equals 3. And so you told me that y is 3 over 2. Putting that together as a coordinate, we get 0, 3 over 2. And then Arisa, when it's crossing the x-axis, we say y is 0. So we get x equals 3. So we get 3, 0. Very, very simple for that bit that we've got there. I've written down here, because I like to always try and think about what kind of mistakes people might make. What mistakes do you think is easy to make? I've said mixing it up, so putting the answer as 0, 3 instead of 3, 0. Sometimes people could switch the coordinates the wrong way around. And the other mistake is sort of what we've spoken about already, is that if you set y equals 0 to find the y-intercept, or x equals 0 to find the x-intercept, it's the opposite of what you expect it to be. So often I will draw a graph to remind me, oh, crossing the x-axis, the y-coordinate is 0. It's easier for you to remember, it's always like the opposite of what you might expect. Okay, we're going really fast through some of these things, which is good. Recapping the gradient. So again, this is stuff that I think it was Redwan mentioned at the beginning of the lesson. The gradient is the steepness of a line. And it tells us what y changes by as x increases by 1. I actually think that's really similar to the definition that you gave me. You said, how does y change as x moves up by 1? So if the y value increased by 6 as the x value increased by 2, what is y increasing by for each unit increase of x? 3, pretty simple. And how would that give us a suitable formula for the gradient m? So this is what Arifel discussed with us earlier. He said that m was equal to the change in y over the change in x. And this little triangle symbol that I've said here is just a symbol that might be useful to become familiar with, especially if you do physics. I think this comes up a lot in physics. It's, this triangle is the capital Greek letter delta, and it means the change in. So this triangle is delta y over delta x. And I think you've probably seen a similar delta when you've been looking at differentiation with Mr. Udin. I think you may have seen this version of delta, which is a lowercase of delta. And you should have seen that version when you were looking at differentiation. There is an alternative form for this, this gradient formula. You could say that m is equal to y2 minus y1 divided by x2 minus x1. I've got that down here written as well. And that is for when you've got two different coordinates that you have here. It is exactly the same formula. We're talking about how y changes and how x changes. Something that's very important to notice, though, is the y2 and the x2 have to both be on the left-hand side, or the y2 and the x2 have to both be on the right-hand side. You couldn't have a 2 here and a 2 here. It always has to be the first coordinate that you're deciding to use goes here, and the second coordinate that you have goes here. So you have got here 4 questions that I want you to have a quick go at to find the gradient of the line that goes through these points. Number 4, think carefully about what it says. It says, show that the points A, B, and C all lie on a straight line. I'm asking you about gradient here, so think about how the gradient may be able to help you with this. I'll give you a couple of minutes to do this, so I'm going to pause the video here.